Tiny plankton that lived in the sea 100 million years ago sank to the ocean floor as they died. Now, as mud and sand build up over the top, it compressed the plankton to form soft limestone chalk, a material called calcium carbonate. If you've ever used chalk to draw on the footpath, the chalk that you used may have been made from skeletons of ancient microscopic plankton, compressed over millions of years into limestone. Our ancestors used chalk to make some of the earliest examples of art. This creativity took a certain superpower. Imagine the creativity and cleverness it took for early humans to find this ancient chalk and think, I'm going to use this to make art and pictures. And what if I told you that this is just part of a superpower waiting to be discovered? Join me and the experts and scientists from Melbourne Museum, ScienceWorks and the Immigration Museum as we uncover the superpower.
Becoming an astronaut is the culmination of a childhood dream. I always wanted to be an astronaut. When I was at high school, I was asked to write down 3 things I wanted to be when I grew up, and I just wrote one: astronaut. I want to show you something that connects me to space every day. It's my phone. Phones are pretty handy. We can use them to communicate, to take photos, and even find our way around. But have you ever wondered how our phones know exactly where we are? Thanks to advances in technology, we have a system called GPS, which helps us find our location anywhere on Earth. It works by having a network of satellites orbiting our planet. When you open a map app on your phone, it sends a signal to these satellites up there, which send a signal back to your phone. By measuring how long it takes for the signals to travel, your phone knows your exact location. This is how it knows if you're at home, at school, or anywhere else in the world. But did you know, long before phones could do all these amazing things, they were just used for calling people. And now our phones talk to satellites. Ooh, I better take this one.
This is a fascinating piece of history. It's an old-fashioned earthquake detector called a seismograph. It was used at the Melbourne Observatory to detect earthquakes in the old days. Have you ever wondered how buildings stay standing during an earthquake? When there's an earthquake, buildings can shake, but people have invented some very smart ways to keep these structures safe. Base isolation is one way to minimize the impact of an earthquake. It's when you separate the base from the rest of the building. When the base of this type of building shakes during an earthquake, the structure itself remains steady. The building is isolated from the force of the earthquake. Engineers are incredibly clever. They come up with solutions to overcome challenges in our world. Not only can they design buildings that are really strong, they've made computers, like this old one, really small and much more powerful.
Is it a spider? A zombie? A robot? In science, that's enough to freak out an arachnophobe, or anyone really. Scientists have made robotic grippers from dead spiders called necrobots. When we move, we use muscles. The bones of our skeleton are moved by muscles that work in opposite pairs, flexors and extensors. Think of your upper arm muscles. You flex your biceps to curl your arm up, and you extend your triceps to straighten your arm back out. Well, spiders don't have the pair. They only have flexor muscles that go one way. Now, the flexor muscles in the spider's legs naturally want to contract and curl up, but the legs curl or straighten based on the amount of pressure in them. Their body is filled with a fluid that's like blood, and when they want to straighten their legs out, they send this fluid into their legs so that there's more pressure. You may have spotted a dead spider and noticed its legs are curled up. Without the fluid and pressure anymore, the legs go back to their natural flex. The scientists found that they could control how a dead spider's legs moved by connecting them to a robot and injecting puffs of air into them, or taking the air back out, making them straighten or curl. The small size makes necrobots perfect for delicate work, like with electric circuits. Plus, dead spiders are cheap and compostable, so quite sustainable. Spooky, huh? Have you started connecting the dots to uncover the superpower? We've seen the amazing ways that engineers build structures to stay safe when the ground shakes, and even how early humans made art from the skeletons of plankton. Let's continue this journey with our experts as we discover more fascinating surprises.
Behind me is the Westgate Bridge. But have you ever wondered how such a huge structure can be strong enough to hold so many cars? See what happens when I place this dinosaur on this bridge I made. So as you see, my single flat piece of paper can barely support its own weight, let alone a dinosaur. But can we make it stronger? It's a bit stronger, but we can do it even better. Let's fold the paper into a channel shape. Look at that! So the more times we fold the paper, the stronger it gets. Adding vertical walls makes it even stronger. Engineers use similar principles to design real bridges. Bridge builders need to make sure their structures are safe. Engineers have worked out that by changing the shape of the bridge, adding supports, and using strong materials, we can make sure bridges are safe.
Right now, I'm full of potential energy. What does that mean? When things are high up off the ground, they have the potential to fall. Potential energy is energy that's just waiting to be used. As I slide down, I'm turning that potential energy into kinetic energy. That's the energy of movement. There are other ways to build up potential energy too, and engineers have built ingenious machines that use potential energy in our everyday lives. I'm going to show you how you can make one yourself by weaving popsicle sticks together. Begin with 2 popsicle sticks in an upside down T shape on a flat surface. Then slide this first one to make it a wonky T. Place a 3rd stick parallel to it. Now, this is gonna get a bit trickier. Place a 4th stick crossing the other way under the first, but over the other 2. Add another stick parallel to the one you've just placed, crisscrossing so that it's over the left and under the right. You'll have to keep putting pressure on the end that you're building. That's the energy building up. If you need someone's help to hold sticks down, you can do it together and share the science with them. Keep adding sticks, crossing over each way, over and under, building up that energy. And when you let go, all of that potential energy is quickly converted to kinetic energy as the popsicle sticks spring back to their normal position. Potential energy is all around us. Engineers use it to create amazing things, from roller coasters to bow and arrows. It's all about storing energy and then releasing it. So that's why I'm full of potential energy. Can you think of ways that potential energy helps us solve problems or makes life a little bit more interesting?
Have you managed to uncover the superpower that we've been exploring? We've explored how engineers ensure our buildings and bridges stay standing, how we can harness potential energy, and even how early human beings used ancient plankton bones to make art. All of these fascinating abilities point to one remarkable superpower: ingenuity. Ingenuity is more than just solving problems, it's about thinking creatively and finding new ways to make our lives better. It allows us to see challenges as opportunities, to innovate and to develop solutions that can change the world. Ingenuity is a creative force we all have. By harnessing this superpower, we can continue to improve our lives and the world around us. Thanks for joining us on this adventure. If you like this episode, you can find loads more activities and videos on the Science is a Superpower website. Just search for it or follow the link in the video description. Keep exploring, keep asking questions, and keep sciencing.